Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most merciful and the beneficent. I am Muhammad Qasaza and I am going to represent lecture number 13 related to the topic internal resistance of a supply. Means there is a resistance inside. Potential difference is known as internal resistance. So the step number one is the resistance present inside all supplies or a potential difference is known as internal resistance of a supply. This resistance which is present inside supplies is very small as compared to the resistance in a closed circuit. Means basically there are two types of resistances. One of them is an internal resistance which is present between electrodes of a supply. Means this internal resistance is present inside a battery or a voltage source, and there is an external resistance which is connected across this in a series or in a parallel connection in a closed circuit is known as external circuit resistance. So this is the basic difference between internal resistance and external resistance. So here in this definition, the resistance which is present inside supply is very small as compared to the resistance in a closed circuit. Means internal resistance is very small as compared to the external resistance in a closed circuit which is connected with the electrical potential supply or a potential difference. Thus, all supplies must have some small internal resistances. This statement describes about the resistance present inside all potential differences are electrical potential sources which we use in our daily life, in our daily electronic circuits or in electrical circuits. So in step number 2 I give explanation related to the internal resistance. This internal resistance is described in such a way that in point number 1, when a cell deliver no current, means when there is a no current, the potential difference become equal to EMF which is equal to 0. So the EMF is equal to 0 in a circuit means induced EMF caused by induced current in a closed circuit become equal to 0. When there is a no current, then definitely there will be no EMF, and the EMF is equal to potential difference as we study early in a previous slides or in a previous lecture. Now coming to the next point, when the load resistance R is means when you connect external resistance in a closed circuit across the terminal of the cell or a battery or a potential source, the current I start flowing in the circuit. Means whenever you close a circuit and applied a potential difference, then current will start traveling electrical circuit from positive terminal to negative terminal. Means current start flowing from higher concentration to a lower concentration in a closed electrical circuit when it is connected across potential difference. Means whenever potential difference is applied across the resistor and or a battery, then current will start flowing in a circuit, and the internal resistance becomes small as compared to the external resistance of the circuit. The last point of this explanation is this current cause a voltage drop across internal resistance. Means there will be a voltage drop across internal resistance, means small resistance of the cell, so internal voltage V available will be less than EMF. Basically there are two types of voltages: internal voltage and external voltage. Internal voltage means the voltage inside the basic voltage of a for potential difference device or a voltage source is known as internal voltage, which is present inside the internal resistance of a battery. It is always less than the external voltage, and external voltage is always equal to the EMF. Now coming to the next step, step number 3, we will talk about the mathematical expression in such a way that the current basically I is equal to E over R plus R. We studied this relationship previously. R plus R. Capital R represent external resistance and small r represent internal resistance of a potential difference. So R plus R is the total resistance. So E is equal to V. Now we can write in such a way that the R plus R is is cross multiplied with the current I. So this equation becomes IR is equal to EMF minus IR. The first of all step is this: IR plus I small r is equal to E. This small IR is a positive, and when it will move toward EMF side, it will become negative. So IR is equal to E minus IR. So if a small resistance is neglectable, then IR small IR becomes 0, and IR is equal to V is equal to E. Now V is equal to E minus IR is called terminal voltage, which is less than the EMF E, because of the term IR represent potential drop across the internal resistance R. There are some certain conditions. Terminal voltage is equal to EMF when current is equal to 0. Terminal voltage is always less than EMF when I is flowing, means current is flowing across the circuit. Terminal velocity is greater than EMF, means when battery is being charged. So now last step number 4 is related to the diagram. This is a very simple circuit in which there is a small resistance R is connected across the positive terminal of a battery, and this is the internal resistance diagram, and capital R represent external resistance, and all these resistance are connected in series with battery. Thank you. Assalamu alaikum, and please subscribe my channel, like it, share it, and also subscribe it with your buddies, with your friend zone, with your class fellows. Again, assalamu alaikum, and thank you. Allah Hafiz.